Yeah, good morning to all. Today we are going to start with module number 3, projection of solids, and it carries 15 to 21 marks. So this first page is our note page. You can make 3 columns, 125, 125 each. So let us see, as per the syllabus, this topic solids is classified as number 1. We have to learn the family of a pyramid, then prism and cylinder. So these are the 3 classifications as per the syllabus. Now the pyramid can be, or the prism or the cylinder, it can be any of the following shapes. It can be, or you can say prism or pyramid. This can be a square prism or a square pyramid. It can be a pentagonal prism, okay, or it can be a hexagonal prism, sometimes triangular, and a special category, circular prism. Circular prism is circular prism or circular pyramid. Circular pyramid is also called as cone, but circular prism is called as cylinder. So as per the syllabus, we have these basic shapes. So let us now start with a pyramid first of all. So today we are going to start with pyramid. First of all, let us see how does a pyramid looks like. So if I take an example of a square pyramid, let me draw a square pyramid over here. So we'll try to learn what is a square pyramid. So this is the base of the pyramid, which is a square. Okay, so pyramid looks like this. So if I darken it, so these are the base. This is the base of the pyramid. Okay, these are the various edges. So we have studied in orthographic also. Edge means line, corner means point, and surface is a type of area. So this is how a square pyramid looks like. Now we are supposed to study the various terms used in this. So pyramid is identified by its base. So if the base is a square, it is called as a square pyramid. If the base is a pentagon, pentagonal pyramid. If it is a hexagon, hexagonal pyramid. So the bottom surface, if you look at the base, it's a surface type kind of thing. So this is the base of the pyramid. So you should know these terms by heart. This line what you can see here, it is called as the base edge. So I'll write this as base edge. This is the base edge. Okay, now you can see that two base edges meet at a corner, and this gives rise to base corner. So this is the base corner. Okay, then over here you can see a triangular type of surface. So if I shade this portion, you can see a triangular type of surface, isn't it? So this triangle, if you look thoroughly, it is not a vertical triangle, it is slightly slanting. So this surface, it's a surface, is called as a slant triangular surface. So by heart it right now, slant triangular surface. Then you can see there is a line which is called as an edge, and this edge is slanting again, so it is called as a slant edge. So various terms you have to by heart thoroughly. Now if it is a square pyramid, you will find 4 slant edge. If it is a pentagonal pyramid, there will be 5 slant edge, and so on. All these slant edge meets at the top, and this gives rise to apex. So apex is a corner and is denoted by point O. So remember, in this topic, O is nothing but the apex of the pyramid. Now last part is, if you look at the base of the pyramid and if you try to join the diagonals or the base of the diagonals of the square, you are going to get a point over here. This point is denoted by M. So M is the center of the base of the pyramid. Now if I join O with M, suppose if I connect O with M by center line, that is big dash, small dash, big dash, small dash. So this line connecting the apex and the center of the base is called as the axis of the pyramid. So this line is called as axis of pyramid. Okay, so these are the various terms what you have to understand. And one logical thing is that the axis of any pyramid and the base has to be perpendicular. So they should be perpendicular. Yeah, so this was the apex which was not seen earlier. So these are some of the models which has been prepared for your understanding. So this is a pyramid because you can see there is an apex at the top. It's a pyramid. So pyramid always has an apex. Okay, prism doesn't have an apex. Pyramid have an apex. So you can look at this pyramid. So if I ask you what is the name of the pyramid, so you should always look at the base. The base is a square. So this is a square pyramid. The white one is the surface. So this is the base what we have seen earlier. The black lines connecting the base are called as the base edge. Then you can see the two base edge meet at a point. So this point is called as the base corner. So there are 4 base corners. Apart from that, this white one is a slant surface. So if you look in the top view, you'll come to know that it is slanting on both all the 4 sides, right? So this is not a vertical surface, it's a slant surface. So this is called as a slant triangular face. That is what we have written here. Then these black lines, they are also not vertical or horizontal, they are also slanting. So this is called as a slant edge. All the slant edge meet at the top to form an apex O. So if I just connect the diagonals and locate the center M and join with O, you'll get an imaginary line, and that line is perpendicular with the base. Okay, so that line which is going inside is perpendicular with the base and is called as axis of the pyramid. So this is about square pyramid. Similarly, if you look at the other pyramid, you will come to know from here. So this is a 5-sided base edge, so it is a pentagonal pyramid. So pentagonal pyramid, when you look in the top, it has 5 slant edge, 1, 2, 3, 4, 5, and there are 5 slant triangular face and apex at the top. So this is about a pentagonal pyramid. Similarly, you can see a hexagonal pyramid over here, 6-sided hexagonal pyramid. So this is the base, this is the base edge, 6 base corners, 6 slant triangular face and apex at the top. Now let us start with some of the basic concepts. In solids, all the word problems what you're going to solve will be in the first quadrant. So I have drawn a first quadrant over here where you have VP, HP and XY, and observe is on this side. So first of all, try to visualize from the front view. In the front view, you can see this vertical plane. So I'll write down FV here. FV means front view. So in the front view, we can see the vertical plane, and this vertical plane is always above XY. So try to visualize thoroughly. When you look in the front view, you cannot see HP. In fact, HP will be seen as a line. Or you can say in the front view what happens, HP and XY will overlap and front view is drawn above. So this understanding is required. So as a note, what we can take down over here is, so we can write down like this, that this is the XY line. Okay, and everything above XY is nothing but, so if I draw a small rectangle, this is nothing but the vertical plane. Okay, and this XY line, or you can say this is HP for front view. So HP is over here and front view is drawn above. So this concept has to be clear. So that is what is being told over here. Similarly, if you try to look in the top view, in top view what happens is, if I go slightly behind and look exactly from here, so let me erase this. Yeah, if you look from this side, you cannot see the vertical plane. Instead, vertical plane will be seen as a straight line. So in top view, VP and XY overlaps, and top view is drawn where? On HP. So if you try to, from here, if you, this is the observer, from here if you try to move to the top, you will understand that top view is drawn below XY. Okay, and VP will be seen as a line. So in the second note, what we can write is, so if you look at the same diagram, and if I hide the above part, then I can say, see, this was our XY, right? This was our XY. So if I hide this part, you can understand that this plane is the horizontal plane, correct? And top view is drawn below. So in the top view what happens is, the same XY line is nothing but VP. So this is vertical plane for top view. So this understanding is required while solving word problems in the topic of solids. So apart from these planes, you also need to understand that suppose if I draw a line, as you can see here, okay, so this line is AB. So if I draw a line which is parallel with VP, for example, and is inclined to HP by theta. So what will happen is when you look in the top view, only in this, sorry, not top view, when you look in the front view, so only in this front view you can see the true inclination theta. But if the same line is to be visualized from above, then what will happen is if you project A, if you project B, you're going to get an apparent length. So in the top view, you cannot see this angle theta. So before moving further, you need to understand this very thoroughly, that whenever a line is inclined with HP, that inclination can be seen only from the front view and not from the top view. And here converse of that, so whenever you find a line, for example, let me draw a line here. So if you draw a line which is inclined with the vertical plane by angle 5. So look at this line. So this line is inclined with angle 5 by the vertical plane, and this line is AB, for example. So when you focus in the front, you can just see an apparent length of the line. You cannot see the true length, neither you can see the angle 5. So you need to understand these two concepts, that whenever a line is inclined with VP, it can be seen from the top view, and when a line is inclined with HP, it can be seen from the front view. So these two basic concepts you need to learn. So this idea, if I transfer it in our diagram, so you can understand that this is the vertical plane, this is the front view. So if a line is inclined with HP, so let me draw a line. So if a line is inclined with HP by theta, you can make out that theta only from the front, not from the top. So you need to draw like this, because from this diagram you can see this true inclination theta from the front, and front view is always drawn above XY. So I have drawn here above. Similarly, if you look at this 5 and try to visualize hard, so just try to visualize very sharply here. You can see that this AB angle 5, you can make out this angle 5 from the top view, and top view is always drawn below XY. Okay, it is drawn below XY. So here if I need to draw angle 5, that 5 will be somewhere, it should be drawn like this, below XY, because top view is always drawn on HP and front view is always drawn on VP. So this is the basic concept what is required for solving solids. Okay, now a model is being prepared where you can see VP, HP, and you can see an XY line over here. So let us first understand from the front view. So when you move to the front over here, so carefully observe, you can see HP and XY overlaps, and HP will be seen as a line. So in front view what happens is HP is seen as a line and VP is seen as a plane where you're supposed to draw front view. So remember that HP and XY overlaps in the front. Okay, so front view is drawn always above XY. Okay, now let me place a line which is inclined with HP, as you can see here. Okay, so the line is inclined with HP by angle theta. So this theta angle, that is the angle made by this line with HP, can be seen from the front view. And if I slowly move above and try to visualize from the top view, so in top view what happens is that angle cannot be recognized. It is seen as a line only. See, it is seen as a straight line. You cannot see that angle. Okay, so that is how it is. Now similarly, if you look perfectly from the top view, you can see VP as a line, isn't it? So almost VP seen as a line, and you can see HP, and you can see that if you draw anything on HP, it will be below XY. So top view is always drawn below XY and VP seen as a line. Now let us take place a pencil or a line which is inclined with VP by 5. So see, this angle is 5, and that can be easily read from the top view. So anything inclined with VP can be seen from top view. But if you look at the same pencil from the front, okay, you cannot make out that inclination. Okay, it is almost seen as a straight line. You cannot make out that inclination. So these two fundamentals should be thorough. So the next concept what we should learn in case of solid is, in solids there are two types of question. Let us see type 1. So I'll write down type 1. So in type 1, if I draw medium dark XY line, as you can see here, so in solids the question is divided into 3 stages. If I say stage 1 is here, stage 2, stage 3. So if a question is asked for 3 stages, it carries 15 marks. And if it is asked for only first 2 stages, it will carry 6 marks. So that is why the question might be 15 marks one question, or 15 plus 6, 21 marks it can be asked. So in type 1, if you draw the first diagram here, so there are, each stage carries 2 diagrams, front view, top view, front view, top view, front view, top view, and they are related. So if the first diagram is drawn here, that is the front view. If you start with the top view. So if you start with the top view, for example, then the second diagram should be drawn above. The third diagram has to be drawn besides. The fourth diagram should be drawn below. The fifth diagram besides, and the sixth one is above. So this is type 1 question where the first diagram is drawn in the top view, that is below xy. Okay, now converse of that, type 2 question. So in type 2 question, if I draw the xy here, and again there are 3 stages, stage 1, stage 2 and stage 3. So it can be like this. So suppose now opposite of this, if you draw the first diagram here, that is if you start from the front view, so always above xy is front view, then the second diagram has to be drawn below, third diagram besides, fourth diagram above, fifth besides. So it's a continuous chain, and sixth is drawn below. So now coming back, how will you decide whether the first diagram should be drawn below xy, that is in the top view, or the first diagram should be drawn above xy, that is in the front view? How will you decide that? So I'll make a star mark here, and we will understand 2 important and very strong fundamentals of solids. What is the first one now? Yeah, so as I told you, for any pyramid is identified by its base. So base is the most important part of a solid. Okay, so concept number 1 is somewhat like this. Suppose if a square pyramid rests on HP, as you can see here. So if a pyramid has its base on HP, so this is our horizontal plane, correct? And this is the vertical plane. So if a pyramid rests on HP, so you need to visualize that whether in the front view or in the top view, from which view can you see these 4 base edges? From which view can you see these 4 base edges? So obviously in the front view you cannot see, because in the front view you can see a triangle. But when you look in the top view, and if you project these corners, you can see the 4 base edges. Apart from that, you can also see the 4 slant edge. So the view will be like this. So the conclusion is, if a pyramid rests on its base on HP, then you have to start with that view from where the true shape of the base edge can be seen. So that is nothing but top view. And where is top view drawn? Top view is drawn below xy. And so we have to follow method number 1. That is, top view, you have to start with top view. I hope this is clear. Similarly, the converse of that, suppose if a pyramid, if I draw a square pyramid for example, okay, here, if a pyramid rests on vertical plane, so let me draw a square pyramid. It rests on a vertical plane, as you can see here. So see, this is the vertical plane. Now if you look in the top view, try to visualize from top view. From top view you can only see this triangular face. You cannot see the base edge as a square. But if you look in the front view from this side, you can see the 4 base edges, isn't it? You can see this 4 base edge. So let us project and try to visualize. So you can see a square. Apart from that, you can see the slant edge also. So 2 simple concepts. Whenever a pyramid rests on its base on HP, it is like your drawing sketchbook, which is right now kept on the table. So this is your drawing sketchbook. Okay. So this drawing sketch, the true shape of this drawing sketchbook can be seen as a rectangle from top view. Hence start with the top view, and top view is drawn below xy. So method number 1. Now this is opposite. If a pyramid rests on VP on its base, it is like a wall clock. So this is the wall clock. It's 1010. So this is the wall clock over here, and the true shape of the wall clock can be seen from the front view, isn't it? And where is front view drawn? Front view is drawn above xy. So that's why you have to start above xy. So these two fundamentals should be strongly understood to learn solids. Okay, so as an example, you can see there are three pyramids which are kept on its base on HP. So the base is resting on HP. If you look at the front view of all these three pyramids, you cannot see the base edge, but you can see the triangular surfaces. Slowly if you move up, okay, and if you visualize from the top view, let us see the square pyramid first. So you can see that in the top view, apart from the four black lines, you can also see the boundary of the square, isn't it? So whenever a pyramid rests on its base on HP, in the top view you can see the true shape of the base, as you can see right now. Even if you look at the pentagon in the center, from the top view you can see the base edge as a pentagon, and same is for hexagon. So this is our method number 1. Whenever the base of a solid rests on HP, you can see the true shape of the base on the top view, and hence draw the diagram below xy. That is method number 1. Well, similarly, suppose there is a square pyramid which rests on VP on its base. So if you look in the top view, you can only see a triangle, see like this. And where is the top view? Observe thoroughly. So this top view is drawn below xy. Correct? You can only see a triangle, but you cannot see the true shape of the base edge. So let us move in the front and try to visualize. So in the front view, when you try to look at this one, okay, so this is the front view. So when you look exactly in the front view, you can see the outer boundary as a square, isn't it? So you should always start with that view where the true shape of the base can be seen. Okay, well, the model has fallen down because of its instability. But anyhow, what I wanted to explain, that has been covered. So we'll now start with the first numerical or the first word problem. So to understand solids, I need to put in a different way. So what we'll do is, we'll mark 30 mm from the top edge of the paper and draw a horizontal line. So within this 30 margin, we'll copy down the question later on. Okay, so we need to write the question within this area later on. But next is whatever space is left from this 30 mm till the bottom, approximately in the center, we need to draw a medium dark xy line. So let us draw a medium dark xy line throughout the page. And as usual in lines, we'll write capital X, medium font size, not too large, not too small, and Y on this side. Okay, so that is the medium dark xy line. So here we are going to draw 3 stages: stage 1, stage 2, and stage 3. For that, we will not be preparing any columns because all the 3 stages are interrelated. So if I directly say that this is stage 1, where you are supposed to draw a pyramid which rests on one of its base edge on HP. Okay, so consider that square pyramid has side of base 40 mm and its axis height is 70 mm long. So this is a partial question that you can write later on. So right now, if I say stage 1 is pyramid rests on one of its base edge on HP, so you need to visualize how should we place that pyramid. So if you read this question thoroughly, what should strike immediately is pyramid rests on one of its base edge on HP. It means the pyramid is kept on HP. And the moment you keep a pyramid on HP, you need to quickly visualize that it is your drawing sketchbook kept on the table. So the true shape of the base can be seen from top view, and top view is drawn below xy. So you need to draw the square below xy. So that is the thing what should strike immediately. Suppose here it was VP. So you have to visualize that pyramid rests on its base edge on VP. So the base is kept on VP. Anything kept on VP is like a wall clock, and that can be seen from the front view. Okay, so let us discuss this further. So when a pyramid rests on one of its base edge on HP, look at this part. Can we say that this is that pyramid with the base edge on HP? Answer is no, because here what is happening is the entire base rests on HP, whereas in the question they have mentioned pyramid rests on one of its base edge. Remember, one of its base edge, not the entire base. Look at the second diagram. If you look at this pyramid, here it is clear that this is the base which is in air, and only one base edge rests on HP. So this one is correct. So now if you look at both the diagrams, whenever in the question they mention like this, pyramid rests on one of its base edge on HP, what you should do in the first stage is, in the first stage intentionally you should make the entire base to rest on HP first, and then in the second stage you should make it to tilt such that one base edge will rest on HP. So why it is so, you'll come to know as you proceed slowly. So let us go back to the question. So whenever in the question you find pyramid rests on one of its base edge on HP, you have to understand that this can be satisfied in the second stage. So what you should do in the first stage is, you should say that entire base rest on HP. So in the first stage our objective is what is shown inside the bracket. So we need to satisfy this one. So forcefully or intentionally we should write like this. What is that? So in the question they have said pyramid rests on one of its bases on HP. So intentionally you should do is that, what you should do is that entire base you keep it on HP. Okay. So this will be our first stage, and then in the second stage we are going to tilt. So in the question they have mentioned a square pyramid, side of base 40 mm and height, axis height is 70. So if you look at this diagram, so this base edge is 40 millimeters. So this is 40, this is 40, and see there is an axis which is imaginary and passing from here, isn't it? So the height of the pyramid, that is this vertical height, is 70. So if you look at this pyramid from top view, you can see the base edges, isn't it? You can also see the slant edge. And see, if you look at the rear base edge, it is not in contact with XY. So it is some distance ahead of VP. It is not in contact. Why it is not in contact? If I contact the base edge on VP, so the question should have been like this: pyramid rests on one of its base edge on HP and on VP. So if the pyramid rests on both HP and VP, then only the rear base edge should contact XY line. Otherwise you should leave some convenient gap. Now when you look in the front view from here, the projection of this pyramid falls where? It falls on the vertical plane, and you're going to get a triangle like this, isn't it? So this is the view. So what we are going to do is, look in the top view. We will call this base corner as A, capital A. This is B, capital C, capital D, apex is O. So when you look in the front view, we know that front view is always dash. So A and B will coincide, and you're going to get this point as A dash, B dash. And top view will be small ABCD. C and D will coincide, and it will give you C dash, D dash, isn't it? The projection of AO will be O dash. And in between you are going to get a medium dark axis which is perpendicular with the base. So in the top view, you can see the square as small ABCD, and you can also see the 4 slant edges. So when you draw the diagram in your book, you're supposed to turn HP down. So what is going to happen is, this square will be drawn below XY, and this triangle will be in contact with XY and above. So these two views represents your first stage, where the entire base is on HP, but you're supposed to make it to rest on one base edge later on. So if you look at this model, you'll understand better. This is a square pyramid, the base is a square. And what I've said in the question is, a pyramid rests on one of its base edge on HP. So actually the pyramid has to be like this here. This is the base edge, right? So I want only one base edge on HP. So it should look like this. And on the other side, you will find a gap. So this is called as one base edge on HP. Okay. But what you should intentionally do in the first stage is, you should make the entire base to rest on HP. You'll come to know later why. Okay. So in the front view, you can see a triangle. And in the top view, If you look at the top view, you can see a square, perfect square with 4 edges, slant edges. And see, there is a gap from xy to this base, isn't it? It is not in contact, because if I make the base edge to come in contact, then the question will change. One base edge on VP also should be there. So that's why we need to leave a gap, because in question is not mentioned anything with VP. Okay, so this is the top view where you can see a square with 4 slant edge and apex. So you should start from top view, and then you have to switch over to front view where you can see only one triangular face. Okay, so this corner was A, this is B, C is here, and D is here. So when you look in the front view, what happens? This A and B will coincide and will give you one single point. You can see one single point which is A dash B dash. Okay, from this side if you observe, this is C and D, right? This edge is CD, but CD in the front view will be seen as a single point. It won't be seen as a line. Okay, so this concept is clear to all. So we will start with the top view. We will draw a square leaving some gap from xy, and then we will project and draw the front view of the same pyramid. So by that our first stage will get over. So to begin with this numerical, this word problem, this is a square pyramid of side 40 and axis height is 70 mm. So if I take this corner as capital A, this is capital B, C, D and apex as O. So you should start with that view from where you can see the true shape of the base. So that is the top view. You can see ABCD. And we have seen in lines that top view should be named without dash and in small alphabets. And also there is a gap from here. So see, front view is from this side, right? So standing over here, you need to look in the top. So top view is from here. So this side AB will be perpendicular with the XY line. So this is the XY line, or you can say it is perpendicular with VP. So let us draw the diagram over here. So in this case, leaving some convenient gap from XY, so I'll align the roller scale here, move down, take some convenient gap of 20 to 25 mm, draw a light line, okay, and mark 40 on this. So front and top view has to be dark always. So up to 4, that is 40 mm, I will darken this. Okay, so once this is done, we need to draw a square of side 40. So let us align the scale with the edge of the paper and we will roll back. So this is my first vertical line. Second vertical line is here. I will mark 40 on one of the sides. Align the roller scale with this dark edge, roll down and draw this dark. So referring to this diagram, in the top view we need to name ABCD. So always in the top view we will follow a systematic way. From the right side top you can start naming small a, so name outside the corner, and clockwise sense you can name this as B, C and D. So this ABCD should be medium dark. And as you can visualize, apart from this base you can also see the slant edges. So there are 4 slant edges connecting O. So we need to draw 4 slant edges. So if I connect A with C, and over here if I connect B with D, I will get those 4 slant edges. So wherever the slant edges meet, so that point is nothing but the apex O. So again you have to refer this diagram. So in the top view you can see that this point is O and the axis will lie somewhere vertical. So this is the axis over here, that will lie somewhere vertical. So O and M will coincide in the top view. So in this top view, this point is O as well as M. So we are allowed to write O and M inside. Now because it is a square pyramid, we need to name the any two adjacent sides of the square. So dimensions are important. So two adjacent sides of the square, we will first draw extension line as we are doing normally, and then above the line, neatly medium dark, we need to show dimensions. So here this is the arrowhead, 40 here, above the line, along the line. So any two sides you have to show. Okay, so let us try to visualize. So to understand this, below xy this plane is HP, all of you know, and as per our note, this xy line you have to visualize it's a vertical plane coming up. So this is a vertical plane and this is the top view of the square pyramid. So see, if you look at the top view, so I need to shift this a little. Okay, so exactly when you look in the top view, you can see a square on the outer periphery and you can see the inclined slant edges everywhere, and this is the apex O. So this square pyramid exactly fits with what we have done. Okay, now let us start with the front view now. For that you need to understand one more thing, that see, when you look in the top view, you can see three things. Number one, you can see this vertical plane as a line. Then you can see the object. The third thing is the observer. The observer, suppose this is the observer over here. So if you look at the observer, from the top view you can see his head. So try to look at these three together, no? Vertical plane, object and observer. So in the top view you are looking at. So the diagram what you have drawn just now, this XY line is the VP. Object is over here. So let me keep the object physically over. So this is the object. So this is VP. This is your object. So observer has to be on this side. So I place an arrow mark here. So in the examination there is no need to place arrow mark, but my suggestion is if you place it, you will never make a mistake. So see, this, my hand is the vertical plane. This this pyramid is resting on HP and the observer is looking from this side. So when you look from here, try to visualize, you can see this triangle. So now we are supposed to draw front view, because as per our rule, what we have seen in the note, after first diagram is down, second has to be drawn up, third should be besides, and so on. So your first diagram is ready. That is the top view. Now you should draw front view. So front view, you look from this side, isn't it? So when you look from this side, you just turn the object. So what you can see is a triangle. So that triangle we have to draw above. Okay, so that kind of imagination is required. So if I zoom in a little, so this is the top view of the square pyramid. When you take a turn, so because you want to look in the front, so just tilt the object. So see, this is the front view and that should be drawn in contact with XY. So this arrow mark, what is being drawn, you need to utilize this arrow mark while drawing front view. So in bracket I'll write down, while drawing front view. So this represents that whenever you draw front view, you have to understand that observer is looking from this side. So now one concept of ortho you have to apply here. So whenever the observer looks from here, the observer can see everything within 180. So see, total there are 4 triangles. So in the front view, observer can see everything within 180, but you cannot see what is beyond 180. So observer can see triangle OBC because that is near to the observer. So this triangle will be seen, correct? So if I place it here, you have to understand very thoroughly that in the front view, only one triangle you can see. So that is O, this is C and this is B. So when you turn, you can see a triangle OCB. Okay, so let us refer this diagram, what is being drawn here. So try to visualize from the front. So the projection of A and B, so if you look at the projection of A and B, so look in the front view, A and B will coincide and there is a single point A dash B dash. Why it is dash? Because it is front view. So C and dash will coincide and here you will get a single point C dash D dash. Projection of O will fall somewhere here called as O dash. So if you join these 3 points, you will get the front view like this. So front view is always dark, we know that. Okay, so in the front view, you can see a triangle. So that triangle is for the front face. Okay, so let's start with this. So look at this diagram. When you project A and B, on xy line. So this point will give us a dash b dash. So see, there is no need to project this line AB beyond xy, because you know that it forms a triangle. So unnecessary, there is no need to project. Then project CD till xy. You will get C dash D dash over here. Then you have to project O over here. So parallel to this line CD. So from point O, I'll project it up. Okay. So now see, there is a difference when you draw the square triangle like this. So in middle there is no edge, so you can draw axis here. But if I draw the triangle slightly tilted, object lines comes first, and behind that you will get an axis. So in that case you should draw the object line first. So whenever you find three edges of a square pyramid, then you should draw the edge. But when you find two edges of a square pyramid, in that case you have to draw the axis in the center. So referring to that, kindly look from this side. There is no edge in the center, and because of that we need to show axis line over here. So here big dash and small dash combination, we have drawn the axis line. In the question they have said axis height is 70, so with scale you can mark 7, or you can say 70. That point is O dash, because front to axis is dash. Join this dark with the base edge A dash B dash, and this dark over here. Okay, so that is what we have done. Now one point M is missing, so we know that M is nothing but the end of the axis. So you have to show the sign of perpendicularity and write M dash inside. So only M dash point can be written inside, rest everything should be outside the pyramid. And in this case slightly the axis should come out from both the sides of the pyramid. Now in the question dimension is given 70, so we should show the height of the pyramid as 70. So here I'll align the roller scale, slide up, and from here we can show dimension 70 medium dark. So this is 70. So that is how we have completed the first stage. So the requirement is, in the first stage you have to draw two views with dimension. Suppose if you draw this and if you don't cover up the remaining question, out of 15 for this 4 marks are reserved. So you will be awarded 4 marks out of 15 if you end up till here. So now let us switch over to second stage. So in the second stage I have written that axis makes an angle of 30 degree with HP. Okay. So the thing is that what are the important points we have to remember? Let us discuss. So if you read the condition of the first stage, in the condition of the first stage was given with respect to HP. So it is compulsory that in the second stage the condition has to be with HP only. Suppose instead of HP here it was VP, then obviously here also it will be VP. So if the first stage condition is with vertical plane, it is compulsory that second should also be with vertical plane. You will slowly understand when we proceed. Now if you read the second stage, axis makes an angle of 30 degree with HP, but you are not allowed to read this alone. You should also understand that when you draw the second stage, you should carry forward the first stage along with you. So you should read in totality like this: a pyramid rests on one of its base edge on HP and axis makes 30 with HP. So when you draw the second stage, you have to satisfy both the conditions. That is, one base edge should rest on HP also, plus the axis of the pyramid should make 30 with HP. You have to satisfy both the conditions. So let us look at the 3D of the second stage. So this was the first stage where the entire base was resting on HP. But the condition what was written is the pyramid rests on one of its base edge on HP, and forcefully we have made the entire base to rest on HP. That was the first stage. So in the second stage what you should do, you should not forget that first stage is related with the second. So both are related. So when you read the second stage, you should carry forward the first stage along with you. So you should read in totality that the pyramid rests on one of its base edge on HP and axis makes 30 with HP. So look at this. So when you tilt the pyramid, this AB is the base edge which is on HP. Can you make out? And if I extend this AB and look from the top, that is perpendicular with XY or VP. So AB was here. After shifting, AB will still remain in contact with HP. CD will be in air and O will be here. And also if you try to draw the axis, suppose this point is M, and if I extend this, so the axis will make 30 degree with HP. Axis will make 30 degree with HP. So whenever you read a question where axis means it is a line. Line makes some angle with HP. So this should strike immediately. So whenever a line makes 30 with HP, that angle can be seen from the front view. And where is front view drawn? Above. So after you drawn first, second, the third diagram should be above. So if I ask you a very simple question, why we should draw third diagram above? So I often find two answers. Number one, students say, if the first diagram is here, second should be here, so third should be above. It follows a chain. I call that as illogical. So that is an illogical way to answer the question. The logical way is, the condition says axis means a line makes 30 with HP. So whenever a line makes any angle with HP, that angle can be seen from the front, and front view is drawn above XY, so we are drawing above. So I want all of you to express your answers logically. So now we need to tilt this triangle such that this corner AB should be on XY. Okay, now before that, how will you understand whether OAB, is it a slant edge or slant triangular face? How do you understand this? So that what you should do, look at this line and count the total number of points. So you have 1 point on the top and 2 at the bottom, total 3 points, and 3 points constitute a triangle. So this is not a slant edge, it is a slant triangular face. Suppose B dash was not there, you have only O dash, A dash. So 2 points constitute a line, so this is a slant edge. Is it very clear? So you should make out from the namings, is it a slant edge or a slant triangular face? So next step what you should do is, with A dash, B dash and XY, you have to tilt the triangle such that axis will make 30 degree. And one base edge on HP, so it's very obvious that after you tilt, A dash, B dash means 2 points, and 2 points is not a base corner, it is a base edge. So see AB. So this is the base edge. So that base edge will be on XY. Okay, so let us understand both the stages with this model. So in the first stage, you have started with the top view. So you can see the square pyramid rest on HP. So in the top view, you can see the square with all the slant edge. Okay, and this right side edge is A and B. So this is the resting base edge. Okay, and in the front view, you can see only one triangle. So front view is drawn on VP, that is very clear. And because there is no slant edge in the center, you can draw axis over here. Okay. Now, the next step, what is being told is, one of the base edge, so preferably we'll select the right side. So this base edge has to rest on HP. That was the condition for first stage. And the condition for second stage is axis makes 30 with HP. So you need to move this pyramid ahead. Okay. And we need to tilt this such that. So you have to tilt such that. How much you have to tilt? You have to go on tilting such that the axis, unless the axis makes 30 with HP, you have to continue. So suppose this is 30 degree. So you can very well see that the base edge which is resting is AB, but in the front view you can see it as a point. Okay. So see, it is in air. Now one important thing to realize is, look at the shape and size of the triangle in the first stage. This was the first stage triangle. When you tilt this, you will realize that the size and shape doesn't differ, it remains same. So only you have to change the orientation of the triangle. The size, height, length, everything will remain same. Only the orientation of the position will differ by 30 degree with horizontal. And that 30 degree you can see from the front view and not from the top view. So when I start drawing the second diagram, if you look at the diagram, roughly the diagram has to be like this, see here. And this is the axis. So this point will be A dash, B dash. axis and base are always perpendicular, we know that. Now point to be understood is, in the question they have said axis makes 30 degree, so this angle is 30 and this is perpendicular because axis and base are always perpendicular. So if you look at this triangle which is formed below, if this is 30, this is 90, so this has to be 60. So whenever in the question they mention in the second stage that axis makes 30 with HP, you have to immediately understand that the base will make 60 because axis and base are always perpendicular. So now to start with, first you have to mark a random point a dash b dash anywhere on xy and write a dash b dash below. Now instead of drawing axis 30 degree, because if you draw 30 degree first, then the orientation will not be correct. So after you mark a dash b dash and you want axis at 30 degree, so draw base at 60 degree. Okay, so with horizon, now which side we should draw base? So from the left side you have to count 60. So on top it is written 10, 20, 30, 40, 50, 60 is here. Correct. So from here, draw a light line connecting a dash b dash. Now because the size and shape is not going to differ, the quickest way to draw is, see a dash b dash is here, we have marked here. Now on this line base has to lie, so base is over here. Okay, so take AB to M in the compass, take half the distance, a dash b dash to M dash in the compass like this, and from AB cut an arc here. Then take M dash to CD in the compass, they are equal, so here it's CD over here. So we will mark this point as C dash D dash. Okay, so this point is M dash, we can name later on. Now because axis and base are perpendicular, instead of using arc method, okay, we can use perpendicular method also. So you can align the protractor with M dash and mark a point at 90 degree. So base and axis should be perpendicular, so we'll mark 90 here, and with a scale we will connect M dash with this. So now see axis length is 70, correct? So by scale, even without compass, by scale you can directly mark 70 and join this dark. So you need to reproduce the same diagram. That means you're just changing the orientation of the square, that's it. You're not doing anything else. In the center, you need to replace this by medium dark axis line. Okay, so this line has to be replaced by medium dark axis line. It should not be a continuous line. So align the scale and we'll draw big dash, small dash, medium dark. Show the sign of perpendicularity and we can write M dash inside. Now as I told you, dimension needs to be shown. So after writing O dash, we can extend this line, leave a small gap of 2 mm, and we can write this angle as 30 degree because axis is 30 degree with HP. So this is the front view of the second stage. So if you count, first diagram is here, second, third and fourth. So fourth diagram should be here, right? So now see, this is the front view. We need to draw top view of this diagram. So once front view is done, observer should look from this side. So this arrow mark should be utilized while drawing top view. In exam you should not write all these things. This is just for our reference. So there are two arrow edges which you should not forget. So if you compare both these diagrams, which was the diagram we had drawn first? Yes, it is a top view. So once top view is done, and if you want to draw front view, arrow mark should be from this side. So observer should look from here. Now in the second stage, this is the first diagram what you had drawn. I need to draw the next diagram in the top view. So observer should look from this side. Okay. So let us start with the important points, how to draw the top view now. So to draw the top view, these points O, A, B, C, D, M, you need to project it down by roller scale. So align the roller scale with this AB, okay, and roll it. So draw light lines from C dash, D dash, from M dash, from A dash, B dash, and from O dash. Okay, so I have drawn lines from here, projected these lines. Now if you look at this square, points A, B, C, D, O, M, you need to project on in the fourth diagram. So align the roller scale with this XY line, roll down, project A and D, they are in the same line. OM, so I need to go a little bit inside. Okay, so OM is also projected, and finally C to B, that is also done. I'll extend OM slightly beyond this. Okay, so now after you're done all the projections, what you should do is, from the third diagram, see, start with A dash is here, so this is the projector of A dash, and correspondingly in this diagram A is here, so the intersection of both the projectors of A, that is your point small a, and that will move above. Similarly B dash is here on this projector, and the next point B is here, so the intersection of both will give you B, so write outside like this. C dash is here, so this is the projector of C dash, and corresponding C is here, so you'll get C over here. Same D dash is the same projector, and D is above, so the intersection will give you D. O dash is here, and projector of O is here, so the combination will give you O. Finally for M dash is on this side and M is from here. Now what you should do, you should make a small medium dark cross sign and write M over here. So see the cross sign, a small medium dark cross sign like this. Well, now there are certain few steps to be remembered while joining these points. What you should do, that is step number 1. So I have placed a compass here. Now see the shadow of the compass, you can see it's below, right? So step number 1, which is true for any solid, is the outline of the shadow is never hidden. It is always a continuous line. So see the outline of the shadow. You will never find a hidden line. It is always a continuous object line. Same story here also. So this is the solid looking from the top. So the outline of the solid is like a shadow which can never be hidden. So you need to draw this dark. So when I say outline, what you should do, connect O with the outermost point, that is B and A. So let us start sequentially. So from O, if I move towards B, double trace it. From B, you have to move towards C. So you have to follow the path very strictly. O to B, B to C you have to join. Double trace dark. C to D you have to join. D to A you have to join. And A to O you have to, A to O, you need to join this. So the outline of a shadow is never hidden. So you need to double trace and make this dark. That is the first step. Now what is step number 2? Let us see. Step number 2 is observe looking from here. So you need to compare apex with the base and decide which is near to the observer. So if you draw locus of, so when I say compare the base, in base there are so many points. So what you should do is you have to make one CR of the base. So here the CR of the base, let M be the CR. So if you look at the locus of O and locus of M, you need to compare from top view and find out which is near. So here apex is near and base is away. And if base is away, it will not be seen. And in engineering graphics, if a surface is not seen, it is drawn hidden. So out of ABCD, see ABCD is the base. Out of ABCD, the line which is left out should be drawn hidden. So AB is the left out line. So here you need to draw AB hidden. Okay, so AB has to be hidden, remember that. Now I'll show you one more method also, which is a very good method. What is that? Orthographic is nothing but projecting parallel rays of light. So suppose like Earth and the Sun, so the source is emitting parallel rays of light. So the light will fall from the area starting from O dash up to C dash D dash. So you can see everything from O say CD because you're looking from top view. So you can see everything from O say CD because CD is the maximum extent. You cannot see what is beyond that. Okay, so you might have studied, right? Half part is light and half is dark. So O to CD will be in a light portion and remaining will be in dark. So because the bottom half is in dark, you cannot see AB because AB is beyond 180. Therefore AB has to be hidden. So I think this method is also a good method. So here AB has to be shown hidden. So A to B, you need to double trace and draw a hidden line like this. Okay, so now that is not the end. The next step is you should carefully look at the base and find out which are the dark and dotted corners. So when two dark planes of a base meet, it is called dark corner. So see, D is a dark corner, and from dark corner you should draw dark slant edge. Suppose AD and CD was dotted, which is not possible. So if D was a dotted corner, then you should draw dotted slant edge. And what is a slant edge? Slant edge is a line joining the base corner with the apex. So because D is a dark corner, draw dark slant edge from OD. So see, this was very difficult to visualize. That you can see one more triangle in the side also. And from here you should join O with C, because C is also a dark corner. So if you don't want rote learning, and by understanding if you want to make out, so again look at this diagram. So you're looking from the front view, you can see everything within 180, that is your scope. So can you see slant edge OC and OD? That is the question. So whether OC OD lies within 180 or beyond? So answer is within. So because OC and OD lies within, in the top view OC and OD can be seen. So it is as simple as that. Okay, finally what you should do is you should draw axis. Now when you draw axis, you need to take care that axis needs to start beyond O, as you can see here, and you have to end exactly at M. This shows the end point of the axis. Like this you have to end. You should not go beyond M, but here you need to go slightly beyond O. So have you understood one thing, that the axis is parallel to VP, because this is top view, and in top view VP is seen as a line. So in top view, if you look at, two things you have to understand. Axis is parallel to VP right now. Okay, and AB is the base edge which is perpendicular to VP. So right now AB is perpendicular. So in the question they have not mentioned that axis is inclined to VP. They have said axis makes angle with HP, and that you can see in the front view. So that is how these 4 stages are being done. So this was the pyramid where axis is making an angle of 30 degree with HP, and the base edge AB is resting on HP, as you can see here, and this is in R. So when you look at this pyramid from the top view, let us try to visualize. So in the top view, when you visualize, okay, so in the top view when you visualize, you can see some portion of the side squares. So try to understand that apart from the black edge, you can see some portion of the side squares that were drawn dark, and that was difficult to visualize. So you see in the top view, axis is parallel with the vertical plane. It is not inclined, but we want inclination from the front view. So right now the axis is inclined at 30 with HP, correct? But it is parallel with VP. Okay. Now let us clarify one small doubt. When we started with the first stage, I had asked you to draw a square of size 40 mm. So what is the reason that we have drawn square with this orientation? Because the square could have been drawn like this also. This is also a square, right? If I turn the orientation, and if I say this is A and this is B, C, D, O and M is in the center. So how will we understand which is correct and which is incorrect? Okay, so let us see the logical answer behind this. So the question is very simple. This was the square in the first stage. Okay, the square was like this. Why we have not drawn the square with this orientation? So I mean to say, we have drawn the square with base edge on the right side. Why we not kept the corner on the right side? What will have happened if I keep a corner on the right side? So the answer is, if I keep corner on the right side and if I draw the front view, so you'll get the front view like this, and this point will be a corner. This point is a corner. Then in the second stage, when you tilt, so you'll understand that corner is resting on HP, and what they want the base edge on HP. If you look into if you look more precisely, suppose if a student has drawn the square like this. Okay, if I say this is A, B, C, D, and this is OM, and when you project all the points, you're going to get a triangle. But remember here, this will also be a edge. Then in projection of A, you will get only A dash here. This is B and D, so center will be B dash, D dash, here C dash, here O dash. So O dash A dash 2 points will give you a slant edge. So remember, this is nothing but a base corner. What is A? It's a base corner. So in the second stage, when you tilt the solid and when you draw like this, so the you need to tilt minimum. The rotation should be minimum, and as per the requirement of 30 degrees. So A dash will be here, isn't it? O dash. Orientation will remain same. It will not change. B dash, D dash in the center. C dash is here. So now if you look at this diagram, base corner is resting on HP. And what they've asked, base edge should be on HP. This is the greatest difference. So in this diagram, if you compare, A dash B dash represents 2 points, that is, it's a base edge. Here it's a base corner. So this concept has to be clear before we proceed. So in the question, if I mention like this, pyramid rests on one of its base corner on HP, then this would have been correct. Okay, so there are two orientations. If you want base corner resting, place the corner on the right side, very simple. If you want base edge resting, place that base edge on the right side. So right side is our reference side. So if you want base edge on HP, right side should be base edge. And if you want base corner resting, then that corner should be on the right side. So let us quickly look at this. So this is the top view, and look at the right side, it is a base edge. So when you turn the pyramid like this, the base edge will rest on HP. So if you look thoroughly from the front, and if you look on this side, the base edge will rest on HP, isn't it? So the resting edge is the base edge. But if I change the orientation and draw the square like this, so on the right side, I'll place a corner. So if you look in the front view, instead of a plain surface, you will find two triangular face, which is separated by one vertical slant edge. Can you make out? There are two triangular face. Now on the right side, you will find there is a corner. See, this is the corner here. There is a corner on this side. This is the corner. So when you look in the front, and when you now tilt, let us tilt the axis by 30 degrees. So you have to tilt minimum. Only minimum rotation is allowed. So when you look at the side, you will find that only a corner is resting. Rest everything is in air, isn't it? So corner is resting over here. Okay. So in the top view also, you can find two triangular face with the corner resting. So very simple. You just need to hold the pyramid and turn like this. So if the right side is a corner, then corner will rest. Simple. If the right side is a base edge, and when you tilt, base edge will rest. Okay, so stage number third diagram, second diagram, first diagram, right side base edge. If right side is a corner, first diagram top view, second diagram is the front view, third diagram tilt. So corner will rest. So now we'll move on to the third stage. So as we discussed before, if the first diagram is drawn here, first, second, third, fourth, the fifth has to be drawn here. So again, whenever we draw the third stage, you should not forget the first two, because it is a part of it. So these are the progressive stages. First stage is here, second is here, third has to be here. Okay, so the third diagram has to be drawn down. So 1, 2, 3, 4, 5. But why it is down? What is the logical reason that we have to draw top view first? Let us learn. So for that, let us read the third stage. Resting base edge makes 45 with VP. So see very clear. The base edge which is resting makes 45 with VP. So first of all, decide whether base edge is a line or a surface. Yes, it is a line. So if a line makes angle with VP, from where you can see that angle, front view or top view. So see, this line makes angle with VP. So that angle can be seen from top view. Same way here, resting base edge means a line, and that makes 45 VP. So that angle can be seen from top view. So we should start with top view. So if I ask you, look at this diagram and tell me which base edge is resting. So be very clear. ABCD is the base edge. ABCD are the base edge. So out of ABCD, which is resting, difficult to make out. So look at the third diagram, this one. So in this diagram, it is very clear that A dash B dash is the base edge which is on HP. means AB is the resting base edge. So when you read this third stage, you should read like this: resting base edge, it means AB. So you should read like this: AB makes 45 VP. That's all. Next part we'll see a little later. So AB makes 45 VP. So right now you need to be very clear that anything with VP, look in the top view. Any angle with VP, look from the top view. So right now if you extend this dotted line AB, it is perpendicular with XY. It is not at an angle, it is perpendicular, 90 degree. So what you have to do is that you have to tilt this diagram such that this AB will make 45 degree, and along with this AB, the entire pyramid should turn by that angle. Isn't it? So some basic revisions. What is that? It's clear that we are going to draw the top view. So for top view, you know that my hand is the vertical plane, so I'll write down this is VP. The space below VP is HP, and observer has to be here. Isn't that clear? So V plane comes first, object comes later on, and at the bottom you have an observer. Now read the next part of the question: apex near to observer. So without changing the shape and size, you need to tilt this diagram such that AB should make 45 with VP and apex should be near to the observer, because in the top view what happens always, as we have seen in the first stage, if you're drawn top view first, arrow mark should be here. So same here, assume that you've done this diagram, the observer should be here. So you have to tilt the diagram such that after you orient the diagram should look like this. See, the diagram should look like this. So apex should be near to observer. Okay, and if you draw the other way around, for example, if you draw like this, then what you can say is apex is away from observer. Apex is away from observer. So minimum rotation, hold this, take a turn such that apex is near to the observer, and the resting base edge AB must make 45 degree. So if you look at this hidden line, that should make 45 degree. So automatically this edge will also be 45 because AB and CD both are parallel. So AB should make 45 and O should be near to the observer. Well, so this is our new observer. So observer always faces the vertical plane. So observer is over here, correct? So now look at the top view of the second stage. Okay. So this edge right now is perpendicular. If you extend this edge, it is perpendicular to VP, isn't it? Okay, and observer is over here. What does the third stage says? That this edge has to be 45 degree VP. Right now it is 90. I want this line to be 45 degree. As I told that this line and the resting edge, they are parallel from the top. So parallel you get on the hidden line, right? So the hidden line and this line are parallel. So because you cannot see hidden line, I am referring this line. So this line should be at 45 degree with VP. Right now it is at 90 degree. And plus the apex should be near to observer. So in top view, when you draw top view, you have to visualize that VP is seen as a line, then comes the object, and below that observer. So line, object and observer. So now what we need is, this is the observer over here. Let me take out the eraser. So this was the second stage. Okay, this was the second stage. So in the third stage what we need is, in the third stage I want apex near, so you need to turn like this. So when apex is near, you cannot see the base becomes hidden. And if the apex is away from the observer, so in the front view you can see some portion of base. So that can be seen later on. Now let us see. So the resting base edge will make 45 degree. Let me turn by 45 degree. Okay, just a minute. See now in the top view, this is that base edge which makes 45 VP and apex is near to the observer. Apex is near to the observer. So in the exam they can twist the question. They can say that instead of apex near to the observer, they can say it is away from VP. So in top view it is away from VP. Okay. So initially the pyramid was like this. If you want apex near to the observer, you have to turn like this, right? See, it is apex is now near, but it has become away from VP. The other type of question what can be asked is, apex is away from observer. So if you make it away, it becomes near to VP. So the question can be twisted like this. So in the top view of the fourth diagram, you need to reproduce as it is and just change the orientation. So after the fourth diagram is done, let us draw the fifth diagram here. So I want AB at 45 degree, or you can say CD at 45, because both are parallel. And you need to hold the pyramid in your hand, and you need to tilt down, because apex should be near to observer, and observer is over here. So observer is somewhere here. So how to start with? See, when you turn the pyramid down, it is very clear that this pyramid should not touch XY. So by mistake, if D touches XY, then the question, there is one additional data they should give, that one base corner is on VP, because XY line is VP for top view. So they are not said like that. So because it's not mentioned, the diagram should not touch XY. Okay, so let us see how to draw the diagram. So first we should draw CD at 45 degree. So arbitrarily mark a point. Okay, and from here we will mark 45 degree. Okay, we will mark 45 degree over here. Connect both the line. Okay, now we are going to hold this and take a turn. So D will be the topmost point, isn't it? D will be the topmost point. So mark D little bit down, because I said told diagram should not touch XY. So this is point D. Now the best way to complete is, look at this diagram carefully. So when you take a turn on this line, C should lie, because DC will be at 45 degree. So C should lie somewhere here. So don't take full length DC. Instead of that, this will be helpful. Take half of CD in the compass. Take half of CD and cut it twice. So from D, you have to cut it twice like this. Dark should be light. So this point is C over here. Now look at the geometry of this diagram. From point D, you will find a line perpendicular to CD. Even from this point, you will find a line, long line perpendicular to CD. And from C, you will find again a short line perpendicular to CD. So from these 3 points, you need to draw 2 short lines and 1 long line that is perpendicular. So align your roller scale. See this 8 calibration I will align. And from here, I will draw a short perpendicular, roll down, long perpendicular, roll down, short perpendicular. So no need to use protractor. So by that calibration you can make out. Then because the size and shape will remain same, take D to A in the compass, and from D cut an arc here. Okay, and just copy paste the same diagram. So align the roller scale with D to C, roll it down, and draw hidden line dark. So if the original diagram is dark, same diagram you need to produce a replica of it. So just producing the same diagram. So say I have drawn that line here, and darken this portion here. So this point is A, this point is B. Now how to get O and M first, let us see. So what you will be doing is, in the compass from DC to O, take the whole length in the compass, or you can even take from dotted line to O, that will also do. So I'll take the whole length in the compass. Okay, now one thing to remember is this axis OM 70? Answer is no, because in the first stage this was 70. After you tilt, this is still 70, but this is the true length. So when you project this 70 now, this OM is reduced. It is no longer 70. Let us keep a scale. So it has reduced to 62. So remember, this is not a true diagram. It is an apparent diagram. That is a view. So now this point is O. Join A with O dark. Okay, and just reproduce the same diagram, O to B dark. So look at the diagram number 4 and just copy paste the same diagram. So apex is also near to the observer. Resting base edge makes 45 degree. Now for point M, take O to M in the compass. It is not 70, remember that. It is an apparent length. So take O, cut here, mark a cross sign, write M over here, and now draw the axis. Okay, now further, as we have been learning right from day one, only show those dimensions which are given in the question. So I need to mention 45 degree here, but they have clearly said in the question that resting base edge makes 45 degree. So it is clear from diagram number 3 that AB is the resting edge and not CD. CD is in air. So here what you should do, you have to extend AB, leaving a gap of 2 millimeter, and then a horizontal line, and you should neatly write down this as 45 degree. So I understand that CD is also 45, but dimension should be those which are given in the question. So that is how the apex is near to the observer compared to the base. So after 4th diagram, 5th diagram, 6 should be drawn here. So step number 1, project ABCD OM from here as well as now from the front view. So the combination of both will give you the points over here. So let us do that.
Hello.
So let us start projecting. I'll align with O dash, roll it here. See, first point is C. I'll project C up, then B, M, D, A, and finally O. Yeah, so I projected all the points from here. Now we need to project all the points from the front view. So parallel to XY, we will roll this up. So AB is in ground only, so nothing to worry about AB, and O is a bit above. Okay, so I'll extend O slightly here. So you need to prepare a chessboard by projecting from both the sides. Now point A is over here and here A is with the ground, so the combination of both will give A dash. Because now we are drawing front view, it should be dash. Second, B is here, so go in sequence. After A, B is on this side and here B is with the ground, so the intersection will give you B dash. So you should be very careful while marking. By mistake, you don't consider any other projector. So by C is here and C is in air, so point C dash is here. Then comes D and D dash. Okay, apex O is here apex is on this side, so combination is O dash. Yeah, we forgot to mark M dash from the front view, so align with this one, roll up and project M dash from this side. So their combination, you have to mark a cross sign and write M dash over here. So now how to connect these points? So step number 1 remains same. Join the outermost points with dark line. Okay, so let me enlarge a little. So here the common mistakes made are, by mistake students join O with D. So outermost point doesn't mean you have to join with sequence O to D, C, B, A, D and O. Not like that. You have to align your scale and join the shadow of the object. So if you look, if I connect with O and C, you will find that D is within the solid. So if you connect with O and C, this is the outermost point. Then C to B, B to A, and finally A to O. So point D dash, it lies within the solid. So this is the meaning of outermost points. Hope it is clear. Step number 2, always decide upon the base, whether base is hidden or is it visible. Should it be drawn dark or dotted? That is the main important part. So now the difference is, observer is looking from this side. Remember, observer is looking from here. So look from this side and always compare O with M. You will, if you compare O with M, you will find from the observer's point of view, O is near and M is away. So when M is away, you have to understand that base is away and the things which are away are not visible. So draw base hidden. So look at this diagram. Out of ABCD in sequence, the lines which are left out should be hidden. So A to B is already drawn, B to C is already drawn. To C to D, this line will be hidden, and D to A, even this will be hidden. What is another way to look at it? This is, suppose if you switch on a bulb, suppose there is a bulb, okay, you switch on the bulb, so there will be parallel rays of light, for example. So you can see everything from O to C, isn't it? From O till C, you can see everything because that is within 180. You cannot see what is beyond that. So carefully look here. From O to C you can see everything, and hence you cannot see CD. C to D is not seen, so it is hidden. You cannot see D to A, and therefore it is hidden. So these are the two ways to look at. Number one, compare O with M. If M is away, draw the base dotted. Second way to look at is switch on the bulb from here and emit parallel rays of light. So you can see from O to C everything. You cannot see beyond. So C to D and D to A both will be hidden. Okay, so let us draw a hidden line here. So I will connect D to C to D with a hidden line. And then D to A also. Now comes step number 3. Look at the base carefully. From dark corner of the base, draw dark slant edge, and from hidden corner of the base, draw hidden slant edge. So if you look at ABCD, B is a dark corner because two dark lines are meeting. So from B to O, you can draw a dark slant edge. If you look at D dash, it is a hidden corner because two hidden lines are meeting. So it's a hidden corner. So from hidden corner, draw hidden slant edge. So O to B will be dark and O to D will be hidden. To verify this, again switch on the bulb. You can see everything from O to C. So what about O to B? Is it within 180 or beyond? Yes, it is within. So therefore O to B is dark. And within 180, if you look here, see O is within and D is beyond. So you have to consider that OD will not be seen because it is beyond, it is behind. So whatever is behind the source, you cannot see that. So OD cannot be seen. Therefore OD is hidden. So we need to align O with B dash, O dash with B dash, and we can draw this dark. Okay, next we'll align O to D dash and we'll draw this hidden. So we'll join O dash with D dash, hidden. Finally, do not forget to connect the axis. So if you join O with M, you can see the axis over here. So finally, if you look at these three stages in the top view, the first stage top view was like this. Second stage you are tilted like this. Third, now observer is here, so apex near to observer. So look in the front, you cannot see this base, it has gone behind. So in the front view, base is hidden. Also if you look at this diagram, in the front view, if you look here, the front view of the first stage is like this. Second, you have made axis at 30 degree. And third, apex near to observer. So obviously when the apex is near, the base will go behind and you cannot see. So the base is drawn hidden like this. If it was other way around, first stage, second, apex away from observer. So you need to tilt like this. In that case, some portion of the base will be seen. But when apex is near to the observer, that base goes behind and so it is hidden here. So you need to know that drawing first stage correctly will give you 4 marks. Up to second stage, 5 marks will be added. So total you will get 9 if you draw correctly up to here. And the last stage carries 6 marks. So total is 15. That doesn't mean that because 6 marks has a more weightage, you will draw this first. Because nobody, including me or anyone, can draw this stage directly. Because if you measure this square, it's no longer a square now and it won't be 40. You don't know this dimension, you don't know this angle, it is not 30. So everything is apparent here. If you look at this diagram, even in this diagram, this is no longer a square. It has turned into rectangle. Only the first diagram is the true one. So therefore, you cannot draw third diagram without the help of second. And you cannot draw second without the help of first. So they are interconnected. Clear? Now one thing to note is, in the first stage, if the condition is with respect to HP, second should be compulsory HP only. But the third stage has to be the condition with VP. Do not forget. So the question can be of two varieties. First stage HP, second HP, third has to be VP. Another way around, if the first stage condition is with Vp, second should also be with Vp, and the third has to be with Hp. So either the question will be Hp Hp Vp or Vp Vp Hp, any of this. So you have to understand that out of 2 HP, which condition will come first. So whenever you find this kind of word, rest, so resting is always the first stage, because always the pyramid rests first and then we make it to tilt and work. So always rest is required first and then you need to work. So first stage is always the resting stage. This is the point you have to remember. So this note can be taken on the first page. Stage 1, stage 2, stage 3. Type A question is HP HP VP and type B is VP VP HP. So what else you should remember is stage 1 is always a resting condition. The resting condition always indicates stage 1. And second thing you should remember is apex away, or you can say apex near, should be satisfied in the third stage. Should be satisfied. So such condition should be satisfied in the third stage. So if I read the actual word problem, it is like this. A square pyramid, side of base 40 mm and length and height 70 mm, rest on. The moment you hear the word rest, understand that it is related with first stage. Rest on one of its base edges on HP. So this statement is a hint for the first stage. And immediately you have to pick up that if our first stage is with HP, second cannot be VP, it has to be HP only. So reading the question further, the axis makes an angle of 30 degree with HP. Axis means a line. Line makes 30 with HP. You can see from the front view, and front view is drawn above. So this is our second condition. Axis makes 30 with HP. And the third condition is the resting edge means AB makes an angle of 45 VP. So see, first stage HP, second HP, and the resting edge makes 45 VP has to be the third stage. Draw its projection when apex is near to the observer. So as I told and written in the note, apex near, apex away has to be drawn in the third stage. So this is the third stage. The third stage has two conditions. Resting edge makes 45 VP as well as apex is near to the observer. So you should develop that skill of breaking up a question into 3 stages. And always it is not like that when you read HP comes first, then second, it's not compulsory that it should be HP only, because this statement can be written at the end also. So if I write this statement, axis makes 30 with HP at the end, okay, then first stage is with HP, so second has to be the HP only. So this statement, if it is written at the end, then don't consider that 45 VP is the second stage. It's not like that. The concept remains same. First HP, second HP, third VP, irrespective of where this statement is written in the problem. Okay, so that is how we have broken up this question into 3 stages. First, rest on HP. Third, axis makes an angle with HP. And last, resting base edge makes 45 VP and apex near to observer. And we have solved the entire part.